the 24-volt circuit, episode 56 of the Gas Service animated series. Modern gas appliances think at 24 volts. A small transformer, a thermostat, a chain of safeties, and a gas valve. That's the whole nervous system. Learn to walk it with a meter and a half. The no heat calls in the world become 10-minute diagnoses. It starts at the control transformer. Line voltage in, 24 volts AC out, typically rated 40 VA. No 24 volts, nothing downstream matters. So check it first. Line in, 24 out. And the small fuse on the board protects that secondary. A blown fuse is usually a shorted thermostat wire or a grounded component telling on itself. The thermostat speaks in letters. R is the 24-volt power leaving the board. W calls heat. Y calls cooling. G runs the fan. C is common, the return path. A heat call is simply R joined to W at the stat. 24 volts sent to start the sequence. Know the letters in any stat wire makes sense. From the W, the call runs a gauntlet. The series safety chain. High limit, rollout switches. The pressure switch proving the inducer. Only then the gas valve. The blower door switch isn't in this chain. It's a line voltage interlock that cuts power to the transformer itself, so check it separately. They're in series on purpose. Anyone open, anywhere, and the call dies. The appliance isn't broken. It's refusing, and one of those switches knows why. The wiring diagram is a ladder. 2 rails, hot and common, and every circuit is a rung. Switches in series with a load. Read it like plumbing. Voltage flows from the hot rail, through the switches, into the load, home on common. Find your dead load on the diagram, and the switches on its rung are your suspect list in order. Here's the technique that makes you fast. Measure across each switch with the call active. A closed switch reads 0 volts across it. It's just wire. The open one reads the full 24, because the whole supply appears across the break. You don't pull a single connector. You walk the chain 0, 0, 0, 24. There's your open. Now find out why it opened. At the end of the chain sits the gas valve coil. 24 volts across the coil and no click, no flow. Kill the power and ohm the coil. It has a spec resistance, and an open coil is a dead valve. Voltage present plus a coil in spec plus no gas is how you condemn a valve with evidence instead of a guess. Two habits keep the meter honest. Resistance tests only with the power off and the component isolated. Never ohms on a live circuit. And respect the difference between the 24-volt side and line voltage. Same appliance, different rules, and the wiring diagram tells you which side you're standing on. "24 volts in one breath. Transformer first, then the letters, then the chain. Read the ladder. Measure across the switches. 0 is closed, 24 marks the break. Condemn coils with ohms, power off. And always ask the last question, not which switch open, but why. Next, how the flame proves itself.